Right. So, the conservation of energy, what is that all about? Usually in Year 10 we can rip this one off without thinking. Energy cannot be created or destroyed.
Only transfer.
Only transferred and transformed.
But what happens to the energy after something like that occurs? So like the chemical reaction occurs and heat energy is released. Does that heat energy
Heat just vibrates into other particles. So heat is just a form of kinetic energy. So this is often a hard one to get a head around in our world because we deal with energy efficiency pretty frequently. So we talk about cars running at, say, 33% efficiency. And what that means, if we put in 10,000 joules of petrol in chemical energy, we only get 3,000 joules out, say. Now that energy isn't lost. It's just transferred into a form that we don't want.
But like once it's transferred into the form, what happens to it then? Where does it go? What occurs?
It just moves other objects. I know what you're talking about. I'll give you a bit more of a hand in a second. Here's a half pipe. So, Alex and his skateboarding friends, he's got a Swivl skateboard because he's unique and he's bringing in trends. So he starts at the top of his half pipe here and he tips over the edge. Drops in. What happens?
Cracks his head.
Let's assume Alex is coordinated. It's a wild assumption, but let's assume it for 3 seconds. What happens? He goes down.
And momentum carries him along.
Now what happens when he's at the bottom?
He reaches his.
Continues to go up.
He continues to travel up. And he flies out the end, right? Oh, okay, what happens?
He starts to decelerate due to gravity and lack of momentum and friction with it.
So he gets to this point here, and then he comes... Shh. Alex, what are you doing?
Man,
Yeah.
I just want to talk.
What are you doing?
Talking.
What am I trying to do?
Teach.
Are you disrupting me from teaching?
Yeah.
What's going to happen if we can't stop disrupting?
RTC.
Do you want that to happen?
No.
Can we get back on work?
Yeah.
Let's go. All right. So he gets to this point here, and he stops. So all his energy's gone, right? He's lost all his energy, broken the conservation. What's happened to his energy? So he started at gravitational. He walked up the stairs. He used his chemical energy to get up the stairs to the half pipe. He's at the top, so he's transformed his chemical energy into gravitational potential. Gets onto the top of the ramp. He then goes down. What happens at the bottom?
He reaches peak velocity.
Top velocity, which means what?
He starts to decelerate from then on.
Yeah, so he's increasing his speed. His kinetic energy is at a maximum here, correct? His gravitational potential is at a minimum. He then continues up to the top. Now I should have drawn this skate ramp to the exact height so that he doesn't fly off the edge, but let's say it's at the same height and I've drawn effectively. He gets to the top. Does he go over the lip? He goes right to the lip and then comes back down, and the same thing happens forever. Why doesn't it happen forever? Shouldn't it happen forever? Shouldn't it happen forever?
Transformed energy.
If he sweats, he loses a bit of it.
I think sweating might be the least of his issues with friction, but I think you're onto the right track. Phil, what is it? Friction between what? So the wheels and the ramp, and his 3-roller skateboard's only going to increase the friction, isn't it? What about any other forms of friction?
He could stop at the top.
Yeah, he could stop, but let's assume he doesn't quite get to the top and he just keeps going forever and ever.
Yes, get some airs.
Yeah, what's...
Would the wheels heat up?
The wheels would heat up, but we've already dealt with the wheels. Is there any other form of friction? Air resistance. So there's two forms of friction. Now that energy, is it lost?
No.
What happens with friction? What is friction? What is friction, Paris? Grip. Which way does friction operate? Horizontally. So if you jump out of a plane, it acts horizontally. So you're falling, but the friction's pushing you that way. You're all good. You just keep going. Which way does friction operate? Opposite to motion. Correct? Where is the friction energy? What is friction energy? Rub your hands together. What's happening? Yep, heat and what else can you hear anything? Sound and heat. So energy, regardless of the transfer, it's not lost, it's just converted into a different type. Now we may not see that as a useful type of energy for us, but it's still being converted into another type of energy. Now the particles that Alex hits on the way down for air resistance, they'll be given a kinetic energy and they'll go hit other particles and hand on their kinetic energy. Make sense? Energy can't be created or destroyed, only transferred and transformed.